Hello viewers, welcome to our channel. I am Dr. Archana Chaube from the Department of Chemistry, Bhopal School of Social Sciences. Today in this lecture, we will be continuing with another topic of phase equilibrium, that is two component system. In earlier lectures, we have dealt with the phase rule for one component system and its specific examples. Now today we will be discussing with an example of two component system, that is silver lead system. So let us begin. The topics that we will be discussing today are the two component system, phase rule which is applied to the two component system, eutactic mixture and silver lead system. What is two component system? In a two component system with the value of phase which is equal to 1, the number of degree of freedom is the highest order 3. That means there are 3 variables that are need to be used. So the diagram that we draw for it will be a 3-dimensional diagram which becomes a bit difficult to depict. So therefore we try to bring it more simpler and we convert it in a 2D diagram using 2 variables. So the two component system can be plotted against either pressure temperature diagrams, pressure concentration diagrams and temperature concentration diagrams, keeping the third variable as constant. Whether in pressure temperature diagram it is the concentration which is kept constant, or the temperature in the second category, or the pressure in the third one. When we talk about two component system, we talk about the reduced phase rule. So what is reduced phase rule? In case of the two component system where two molten solids are taken together, the gaseous phase can be ignored. So pressure is an important parameter for the gaseous phase. So therefore the Gibbs rule which we have stated earlier, it talks about F is equal to C minus P plus 2. So since one of the parameter is being ignored, so we cancel or subtract 1 from it, giving rise to this new rule which is F is equal to C minus P plus 1. So since this is talking about the reduced phase is one of the phase is being reduced. It is only solid and liquid, we are talking about two phases. One of the gaseous phase is not being considered in the parameter. So this phase rule is termed as reduced phase rule and it is applicable for two component system where the two components are in the molten states. Now when we talk about two component system, there is another important term that we know to understand, that is eutactic system. What is the meaning of eutactic system? Silver lead, which is the example which we are dealing with today, is a very good example for eutactic system. Here the two component system, it is such a system in which both the components, when they are melted in the liquid phase, they are completely miscible with each other. But the important point is that even after mixing with each other, they do not chemically react and they do not form a new compound. They maintain their individualities. So such a mixture, when they mix together and such a mixture with a specific composition of the two liquids together and not forming any new compound is known as a eutactic mixture, and such systems are known as eutactic systems. Then we come to another term which is eutactic temperature. What is eutactic temperature? If we talk about two substances A and B, which is in our case silver and lead. So the substance A, the freezing point is generally higher, and as we keep on adding the second substance to it, there is lowering in freezing point, and when it comes to a particular value beyond which further addition of the substance B does not cause any change in the temperature value, that temperature is known as the eutactic temperature, and the composition at which the two substances achieve this particular temperature is known as eutactic composition. So it is a fixed value for any particular system, and therefore when we apply the phase rule for it, this will be a non-variant or invariant system. That means there will be no degree of freedom and it will occur only at a specific temperature and composition value, and this point at which the two compositions will occur, this point is termed as eutactic point. So let us understand this taking the example of silver lead system. In silver lead system there are 4 phases which occur. One is solid silver, then solid lead, then the mixture of two, the solution phase and the vapor phase. when we apply the reduced phase rule, which we have already seen, f is equal to c minus p plus 1, and we apply this formula on the curves that are appearing in the graph. Since this is a 2 component system, so the value of c which is taken over here will be 2. The number of phases which are there is already 2, which we have already specified, because one phase we have subtracted, and applying the rule we find out that along the curve the value for degree of freedom comes out to be 1. That means it is a univariant system. But when the same law is applied on the point O, which is the eutectic point of the system, there, as I already told you earlier, that these points are invariant or non-variant. That means they have 0 value of degree of freedom. We do not have any freedom to change the conditions at which this particular point will appear. This is a diagram for the silver lead system. We can see that the axis showing the temperature and the x axis showing the percentage composition of the two metals. At one end it is showing 100% silver and 0% lead, on the other it is just the opposite, 100% lead and 0% silver. Now, if we want to understand this graph, we can see the line AO. This line AO demarcates the two conditions where the liquid, which is the melt of silver and lead together, this is the melt of lead and silver, this is separated from the melt along with solid silver, whereas on the line OB it separates this liquid from the solid lead and the melt of the two liquids. So, these two lines are separating the two components with each other. When we come to the line POQ, this is the region where only melt will appear along with the eutectic mixture, and the point O which we were talking about, this is the invariant point which appears at the temperature of 576 Kelvin, and the composition ratio of the eutectic mixture of silver lead system is 2.6% silver and 97.4% of lead. So, when we talk about this system, if we take any point P, that means this is representing any solution, the liquid solution which is appearing over here, and gradually we begin to cool it, and during this process as we move down and reach to the point P dash, this is the point where gradually what will happen, that the solid lead starts to precipitate out, because this is the region which is closer to 100% lead. After reaching this point, solid lead starts separating. If we continue to cool it further, we will move on this particular line of OP, and as we continue cooling it, ultimately we reach to the point O, and on reaching point O we will find that the mixture that is obtained, it will have the specific composition of 2.6% silver and 97.4% lead. So, this is the eutectic temperature at which is 576 Kelvin, at which the two mixtures are present together along with one of the solid phase, like the region over here which I am marking, the area PO. This is the region where the eutectic mixture, when I am talking about eutectic mixture, I am talking about a mixture with the composition 2.6% silver and 97.4% lead. Along with that, solid silver is present, and on the other side, if I am talking about, this is the region where the eutectic mixture is present along with solid lead. So, one region is eutectic with solid silver and the other region is eutectic with solid lead, and we have already discussed that the curves are univariant, the point is invariant, and the areas again over here, if we apply the phase rule, it will be bivariant. So, this is about the silver lead system. I hope you must have understood the topic. In the next class, we will be dealing with another example of two component system. Thank you.